Hello there, Algebra 1 students. This is Mr. Kashi speaking. I want to go, this video is going to be on our second day of 10.2, going over some other strategies of graphing quadratic functions. And today the focus is really noticing what moves a graph the way it does, whether it goes up or down, whether it goes right or left, basically how it's shifting from its original parent function. The first thing I want to show you though is this is a Desmos slider, so you can take a parabola, which is written in standard form, and if we were to move the A in our standard form, if we were to make it bigger, it would stretch up, just like our concept says. As A gets bigger, it's going to stretch, and then as A comes down, we're less than 1, it's going to shrink, and then when A becomes negative, it flips down, and then as it gets more negative, it actually stretches more negative that way too. So this would be like -10 as an A. Alright, and then same thing. So that's what A does, is it stretches and shrinks it, and then when it becomes negative, it actually flips it down. So let's bring that back to 1 there. And then if we were to change the B, so this is our parent function right now. If we were to change the B, as B gets bigger, it slides left, but it doesn't slide straight left. It doesn't slide straight left because our C is still 0, and our C is always going to be our y-intercept. So we'll be, put C back to where it is. So as B becomes negative, it actually starts shifting to the right. And doesn't shift straight right. It has to slide down because of our C. So the last thing is, if we were to just slide C, C is the last number in our equation. It's the easiest to track because when C becomes positive, it slides up, and when C becomes negative, it slides down. That's the easiest one to kind of track on whether where it's sliding up or down. So at the end of each one of our examples here, we are going to determine whether it slid up and slid down, all those types of things. Slid side to side, which side did it slide, and all that. So the first thing is finding our line of symmetry. So it's going to be opposite of B divided by 2 times A, which is 1. So this is going to be -2 divided by 2. That's going to be -1. Okay. And so our line of symmetry is going to be -1, which is going to be right here. So hopefully you can see already that when A and B are positive, it's going to slide to the left. Okay. And then -1 is right here, and do a little computer trick here and slide that down. So we have x squared plus 2x minus 8. So now we would still want to do 2 before and 2 after. So this would be -2 and -3, and then this would be 0 and 1. Now in this case, I would want to use the 0 and the 1, so I'm going to plug in these 3. Because we know from our earlier videos that these are symmetrical and they're going to be the same. So I'm going to save myself some arithmetic and put in the easy numbers. So I have 1 squared times plus 2 times 1 minus 8. So this would be 1 plus 2 minus 8, and that would be giving me a -5. And then I will plug in 0. So 0 squared, that's pretty easy. 2 times 0, just as easy. And then I have this -8, so this is going to be a -8 right there. And then finally we got to find our vertex. We have -1 squared plus 2 times -1 minus 8. So -1 squared, that's a +1. 2 times -1, that's a -2. And then we have a -8. So this is going to 1 plus -2 plus -8, this is going to be a -9. Then we're able to slide these two up. We can mirror the -8 up and the -5. So we can go ahead and plot those points. -3, -5, right there. -2, -8, and we have -1, 9. Sure enough, that vertex is on our axis of symmetry. And we have 0, -8, and 1, -5. And then we can come up and draw our parabola like that. So obviously it shifts left. It doesn't shift very far left. It only shifts over 1. It shifted down because our -8. Hopefully you guys are starting to recognize that this -8 means that our graph crosses at -8 right there. So obviously it slid to the left in this case and slid down a handful, went down 9. But that's because our y-intercept has to be -8. So when A and B are both positive, that means we are sliding to the left in some sort of manner. Now the A's, the B's, and the C's are going to change. So the next example that we're going to talk about is what if A is negative but B is positive, just like what we have here. So we'll find our axis of symmetry, opposite of B, divided by 2 times -1. So this will be -4 divided by -2, and this gives us a +2, which means that our line of symmetry will be where x equals +2. And a 2 will go right there. We'll bring this down, -x² plus 4x minus 5. And we will go 2 before, so that'll be 1 and 0, and then 2 after, 3 and 4. I'm going to stick with the easy numbers once again, so I'm going to plug in the 0, 1, and the 2. And then I'm going to reflect them down, just like we have been doing, because parabolas are symmetrical. So here we have 0 squared plus 4 times 0 minus 5. So the 0, 0, and then we have the minus 5 at the end, which makes that a -5. So now we have a -1, or a 1 squared with the negative out front, plus 4 times -1 minus 5. So this would be 1 squared is 1. With the negative out front, that gives us a -1 plus a -4 and a -5. Oh, this is a positive one, sorry. This is going to be plus 4 minus 5. That should give us a -2. Sorry about that. We have negative, then we have 2 squared plus 4 times 2 minus 5. So 2 squared, that would be 4. With the negative out front, this would be -4. 4 times 2 is 8. That would give me a +4 minus 5. This would give me a -1. And we're able to reflect those numbers on down. And we can plot our points. 0, -5. 1, -2. 2, -1. 3, -2. And 4, -5. And we can draw our curve in for our parabola. And as you can see, we probably could have answered this question when we found our line of symmetry, but when A is negative and B is positive, we are going to be able to shift right. It's going to be shifting to the right side of the y-axis. Go ahead and pause if you need to take more notes, but I do have one more example that I'd like to go through, and that is if A and B are negative. So just going through our process, practicing this again. We have opposite of -4 divided by 2 times -1. That's going to be a +4 divided by a -2, and that is going to be a -2. So -2 goes here. We have our axis of symmetry of -2. And then we are going to be plugging in our points. We have 2 before and then 2 after. I'm going to plug in the easy ones down here at the bottom. And go ahead and rewrite that expression in there. Negative x squared minus 4x minus 6. So I'm going to go from bottom to top. And we're going to have negative 0x squared minus 4 times 0 minus 6. And that's going to give us a negative 6 because the zeros don't mean anything here. You could pretty much just cross those out and just get the negative 6 there. Now we have a little bit more arithmetic. We've got to plug the negative 1 in. Negative 1 squared, then we have minus 4 times negative 1 minus 6. So negative 1 squared is going to be 1. That makes it negative out front, so that's a negative here. And then we have minus a negative 4. 4 times negative 1 is negative 4. So this is actually going to be adding 4 minus 6. So negative 1 plus 4 minus 6 gives us a negative 3. Then negative 2 here, we would have a negative, and then negative 2 squared minus 4 times negative 2 minus 6. So we have negative 2 squared, which is 4, but the negative out front makes this a negative again. This is going to be 4 times negative 2, so this is actually going to be change, and we're going to be adding 8 minus 6, and then this will give us a negative 2. So then these get translated up here. We got negative 3 and negative 6. And then we can plot those points onto the graph. Negative 4, negative 6, negative 3, negative 3, negative 2, negative 2, negative 1, negative 3, and 0, negative 6. And we can draw our graph in. That. And so if A is negative and B is negative, you can see that our axis of symmetry was negative 2. This would mean that we shift left. So that just means that our parabola, whether it's pointing up or down, well, in this case, as soon as you know A is negative, it's going to be pointing down. But we know that it's going to be shifted left. Because A is negative and B is negative once we find our axis of symmetry. So hopefully these examples help. You'll be graphing more of these quadratic functions in your homework.